Hi students, this is Anita Raj, your chemistry mentor, welcoming you for one more important session in chemical kinetics. Yes, it's numericals today. We shall see some important numericals in this part 1 video now. Read the first problem students. The decay constant of carbon 14 is 2.31 into 10 to the power minus 4 per year. Its half-life is, see, four options were given. Okay, 2 into 10 to the power 3 years, 2.5 into 10 to the power 3 years, then 3 into 10 to the power 3 years and 3.5 into 10 to the power 3 years. Okay. See here, they have given the decay constant. What do you mean decay constant? This decay constant of carbon 14 is nothing but the rate constant. Okay. So let us write the given data first. See the decay constant or the rate constant. Okay. Rate constant. K. Okay. K value is given, that is 2.31 into 10 to the power minus 4 per year. Okay. So what else is given? So this is the main data, right? It's the main data, and you're asked to calculate T half. Okay. T half for this decaying reaction. Okay. That's the question asked. So now you should know what is the formula for T half. T half is equal to 0.693 by K. Is it not? By K. See, the K value is given. So you can directly substitute the value and find out the answer. So T half is equal to 0.693 divided by 2.31 into 10 to the power minus 4. Okay. So after simplifying, you'll be getting the answer 3000. 3000. That's nothing but 3 into 10 to the power 3. Okay. So years. Okay. So that's option C is correct. Understood, students? Read the question, students. The formula of rate law for a reaction is expressed as R is equal to K into concentration of chlorine into concentration of nitric oxide. Find out the order of the reaction with respect to chlorine, NO, and also the overall order of the reaction. See, four options were given. See, in this question, they are given the rate law. Okay, let me write and have the rate law. R is equal to K into Cl2 into concentration of nitric oxide, okay, to the power 2, right? See here, this is the rate law, and they are asking you to find out the order of the reaction with respect to chlorine and also with respect to NO and also the overall order of the reaction. Okay, what do you mean by the order? First, order is the sum of the powers of the concentration terms. So these two are the concentration terms. Okay, this is enclosed in a square bracket, right? So this is the concentration term, then this is also concentration term. So order is nothing but it is the sum of the powers of the concentration terms. So what is above? What is the power of this chlorine? It is 1. What is the power of NO? It is 2. Sum of the powers means 1 plus 2 gives 3. So the overall order is 3. Okay, 1 plus 2, it is 3. What is the order of the reaction with respect to what is this respect to chlorine? With respect to chlorine, see what is the power above chlorine? This chlorine, it has 1, is it not? So with respect to chlorine, the order of the reaction is 1. With respect to NO, the order of the reaction is 2. Okay, so with respect to NO, it is 2. Understood? So what could be the answer? What is the first question asked here? Say order of the reaction with respect to chlorine. It is 1. So 1 comma next question with respect to NO. So it should be 2. It is 2 is about. It is 2. The overall reaction is 3. So next one is 3. Which option has this answer? 1, 2, 3. It is D. Is it not? So option D is correct. Understood, students? Read the question, students. 87.5% of a first order reaction was completed in 42 minutes. When will be the 50% of the reaction gets completed? See, in the problem it's given 87.5% of a first order reaction has got completed in 42 minutes, and you are asked to find out at what time 50% of the reaction gets completed. 50% means half. Is it not? That means half life. They are asking you to find out the half life of this particular reaction. Okay, so let me write and this given data. Say 87.5% of the reaction got completed at 42 minutes. Okay, so they are asking you to find out at what time this 50% of the reaction got completed. Okay, so that's the question. That means they are asking you to find out the T half. Understood? T half, 50% is T half, time taken is T half. Can you just recall the formula which relates this half-life T half with that of the reaction complete, 87% of the reaction completed. So which formula relates? It's nothing but it's T 87.5 percentage is equal to 3 times half-life. Okay, 3 times half-life. So if you want to find out half-life, then you can reshuffle this formula. T half is equal to T 87.5 divided by 3. Okay, so what is the value given here for the time taken for 87% of the reaction gets completed? 42 minutes, is it not? So it is 42 divided by 3. So the answer is 14 minutes. Okay, 14 minutes is the answer. So option C is correct. Understood, students? Read the next question, students. The half-life period of a first order reaction is 13 minutes. Find out the time required for the concentration of the reactant to change from 0.15 molar to 0.03 molar. See here they have given the half-life for the first order reaction, that is T half is given, that is 13 minutes. And you are asked to find out the time taken for the concentration of the reactants to change from 0.15 molar to 0.03 molar. Let us write the data first. Okay, so what are the things given? T half is given. Okay, T half is 30 minutes. Okay, T half is 30 minutes. Then what else is given? Initial concentration, that is from this to that, is it not? So 0.15 molar initial concentration. Then what is the concentration after a particular time? It is 0.03 molar. Okay, and they are asking you to find out the time taken, okay, for the conversion of this concentration, that is 0.15 to 0.03. So that's the question asked. Okay, now we shall write the find out the solution. See here, let me write the formula for T half first. T half is equal to 0.693 by K. This is for the first order reaction. See here, already T half value is given. Okay, and if you are substituting this value here, you'll be able to find out the rate constant. Okay, then you can make use of this rate constant at this initial concentration and the final concentration in the first order reaction rate equation and find out the time taken. Understood? So that's the procedure, right? So let us find out the rate constant using this formula. Okay, so the rate constant K is equal to 0.693 divided by T half. Okay, so find out the answer. 0.693 divided by what is the T half value? 30. Okay, so the answer is K value is 0.0231. Understood? Now we are going to make use of this K value 0.0231 in the rate equation. Okay, for the first order, right? So how come? See, for the first order it is like this, rate constant equation is like this, 2.303 by T log concentration of the reactant in the initial stage by concentration of the reactant after some time. Okay, so this is the formula. Now we are in need of this time. Okay, we are in need of the time taken for the conversion of this concentration. Okay, so we are reshuffling this formula. T is equal to 2.303 by K log concentration of A naught divided by concentration of A. Understood? So you know this value. So not K value, you know. Just now we have found out 0.0231. And A naught value, obviously no. A value also you know. So you can easily calculate this. No, it's a simple problem. So 2.303 divided by 0.0231. 231 log concentration 0.15 divided by concentration 0.03. Understood? Okay, now we can simplify this equation. So just divide this value 2.303 divided by this value. While you are dividing, you will be getting this value, that is T is equal to 99.69 into when you are dividing these two values 0.15 by 0.03, you'll be getting, see, log 5. Okay, now we just multiply these two values, 99.69 into what is log 5, it is 0.698. Okay, so when you are simplifying, you'll be getting 69.58. so when you are rounding this, you'll be getting 70. Okay, 70 minutes. Understood? So the right option is A. Answer A is correct. Understood, students? Read the next problem, students. The rate constant of a first order reaction is 3 into 10 to the power minus 6 per second. The initial concentration is 0.10 m, and we are asking you to find out the initial rate of the reaction. Okay, so the rate constant value is given, and also the initial concentration is also given, and you are asked to find out the initial rate, and the four options are also given. Okay, first let us write the given data. Rate constant, that is rate constant. What is rate constant? K. Okay, K value is given. It is 3 into 10 to the power minus 6 second. Is it not per second? Right? Okay. Then initial concentration. Initial concentration. Initial concentration is also given. That is 0.10 m. Okay. And you are asked to find out initial rate. You are asked to find out the initial rate. Okay, now we shall go for the solution. Here, let us write the rate expression for the first order. What is the rate expression for the first order? R is equal to K into concentration of the reactant. First order means the power to the power 1. Is it not? So now see here these values are given. K value is given. K value is directly given, and concentration, initial concentration is 0.10. So you can directly substitute the value and find out the answer. What is K? It is 3 into 10 to the power minus 6 into 0.10. Okay, so what is the answer? It is 3 into 10 to the power minus 7 ms minus 1. Okay, so what is the correct option? See here, this one, this is not A option. A is correct. Okay, understood, students? Read the next question, students. The reaction A to give B follows first order kinetics. The time taken for zero point 0.8 mole of A to produce 0.6 mole of B is 1 hour. Okay. What is the time required for the conversion of 0.9 mole of A to produce 0.675 mole of B? See here. See in this problem, two values were given. Okay, two data. That is, that the first data is 0.8 mole of A is getting converted to 0.6 mole of B in 1 hour. Okay. So, and they are asking, if the next question is, they are asking you to find out the time taken for the conversion of 0.9 mole of the same A to 0.675 mole of B. Okay. So, the values were given. Okay. 1, 2, 3, 4, 5. 5 data were given. So, using the first three data, it is possible to find out the rate constant, because two concentrations were given and the time is also given. So, it is possible to find out the rate constant using the first order reaction rate equation. Okay, and then after finding out rate constant, that value can be utilized here in this data to find out the time required. Understand? Let me write the formula now. K is equal to 2.303 by T log concentration, the initial concentration divided by concentration of the reactant after some time. Okay. Now this is the formula. Now in this formula we are going to substitute all these values and find out K. Understood? So that's equal to 2.303 divided by, what is the time? It is 1 hour. Is it not? 1 hour log concentration. You know what is the initial concentration? It is 0.8. So 0.8 divided by, what's the final concentration? It is 0.6. It's not 0.6. Okay. Now simplify this. So after simplifying this, we will be getting the answer as 0.288. What is the unit for the rate constant for the first order? It is seconds. Here the values are given in R. Is it not? So you can write as R minus 1. This is the unit. Okay. Now what we are going to do? See, we are going to make use of this value, that is K value. K value in the same formula, and we are going to find out T by using these two values, different values, that is 0.9 and 0.675. Understood? So T is equal to 2.303 by K log concentration A0 divided by concentration of A. Now you substitute the second data. Okay. Now what's the value? T is equal to K value we have found out. Is it not? What is K value? It is 0. Here 2.303 divided by 0.288 log concentration of 0.9. Here concentration 0.675. Understood? Now simplify these things. So when you are dividing 2.303 by 0.288, you'll be getting 7.99. Okay, log. When you are simplifying these two, you'll be getting log 1.33. So after finding out, see 7.99, what is the log of 1.33? It is 0 into 0.1238. Okay. So when you are simplifying this, you'll be getting 0.98. So when you are rounding, you are getting a whole number. It's 1 is equal to 0.98 can be taken as 1. So it is 1 hour. So the answer option, correct option is C, 1 hour. Understood, students?
Read the next question, students. The rate of decomposition of hydrogen peroxide at a particular temperature was measured by titrating its solution with potassium permanganate. The following results were obtained. So tabular column is given. Here the time in minutes is given. 10 minutes, 20 minutes. At different time intervals, the volume of potassium permanganate was measured. Initially it was 22.8. Then at 10 minutes it was 13.8. At 20 minutes it was 8.3. Show that it is a first order reaction and find out the rate constant K. Okay, see, using this data you are supposed to find out that whether this reaction is a first order reaction and you are asked to find out the rate constant value also. Okay, so first let me write the formula for the rate constant for the first order reaction. K is equal to 2.303 by T log concentration, initial concentration A0 divided by the concentration at the different time interval. Okay, see here, since 3 different values were given: initial concentration, initial volume of potassium permanganate at 10 minutes, at 20 minutes. Okay, now using this initial value, this is the initial, let me find out the rate constant K1 and K2. We are going to find out K1 is at 10 minutes, K2 is at 20 minutes. Okay, so at these two time intervals, okay, these two time intervals we are going to find out the rate constant, that is K1 and K2. Okay, for both the cases we are going to make use of this value, that is 22.8 as the initial concentration. Okay, so now let me write for K1. K1 is equal to 2.303. What is T1 then? T1 is 10 minutes, is it not? So 10 divided by 10 log, what is A0? It is 22.8, is it not? 22.8 divided by, what is the volume of potassium permanganate at 10 minutes? It is 13.8, is it not? So 13.8. 13.8. Now simplify the values. What is this? See, when you are simplifying this becomes 0.2303 into 0.218. Okay, so when you are simplifying this, you will be getting 0.0502. Okay, it's in minutes. Okay, minute per minute. Understood? Now we are going to find out K2, just like the same method. We are going to find out K2. So 2.303. What is the time now? T2, it is 20, is it not? So divided by 20 log, what is the initial concentration? Same, is it not? 22.8 divided by, what's the concentration at time T2? It is 8.3. Okay, when you are simplifying this, you will be getting 0.115 into 0.438. Okay, so finally you will be getting 0.0503 per minute. Okay, this is the unit per minute. Since the values are given in minutes, you are supposed to write in minutes. Okay, now so see here these two values, k1 value and k2 value, see both are similar, is it not? 0.050, 0.050, so both the values are same, is it not? That shows that since the rate constant, both the rate constant are similar, it belongs to the first order reaction. So this is correct. So it belongs to the first order reaction, we have proved. Okay, now we are here to find out the rate constant k. How to find out the rate constant? See here we should find out the average of this k1 and k2. Okay, so k is equal to what is rate constant? K1 plus k2 divided by 2. Okay, so what is the values? What are the values? 0.0502 plus 0.0503 divided by 2. So you'll be getting, what's the answer? 0.0503. Okay, so this is the a minute per minute. Okay, so this is the rate constant. This is the rate constant for this first order reaction. Understood, students? Read the next question, students. A study of chemical kinetics of the reaction A plus B giving products gave the following data at 25 degrees centigrade. So a tableau column has been given. In this, the experiment has been conducted 3 different times. That is with different concentrations of A and B, and you have got different rate values. Okay, so 1, B 1.5, and the rate value is different. Okay, see here likewise we are given 3 different datas, and you are asked to find out the order of the reaction with respect to A, order of the reaction with respect to B, and also you are asked to write the rate law. Okay, first what we should do is, first let me write the rate law, general rate law. Okay, I am going to write the general rate law now. General rate law. General rate law goes like this: R is equal to K into concentration of A to the power X, concentration of B to the power Y. Okay, now see based on this general rate law, I am going to fix these values. Okay, and I am going to find out 3 different equations. I am going to write 3 different equations using the same data, using these data in this general rate law. Okay, so this is rate, and this is concentration of A, and this is concentration of B. So using these data I am going to write. Okay, now see, let me write the first equation. What's the first equation? For rate is 4.20 into 10 to the power minus 6 is equal to K into concentration of 1 is 1.0 to the power X. What is B? It is 0.15 to the power Y. Let this equation be equation number 1. Okay, so let me write the next equation. What is the next equation? 8.40 into 10 to the power minus 6 is equal to K into, what is the concentration of A? It is 2.0 to the power X. What is Y? It is 0.15 to the power Y. This is equation number 2. Let this be equation number 2. What is 3? It is 5.60 into 10 to the power minus 6 is equal to K into, what is A? It is 1.0 to the power X. We do not know what is the power, so that's why we have written X and Y. 0.20 power Y. So this is equation number 3. Okay, see, first we should find out the value of X and Y. If so, it is possible to find out the order of the reaction with respect to A and B. See, if you are able to find out X and Y, then we can find out the order of the reaction with respect to A and with respect to B. Okay, so for that I am going to divide. First I am going to find out X. Okay, find X. We are going to find out the X. For this I am going to divide I am going to divide equation 2 by 1. Okay, I am going to divide equation 2 by 1. So what is equation 2 now? Come on, write. So it is 8.40 into 10 to the power minus 6, okay, is equal to K into 2.0 power X into 0.15 to the power Y. Okay, now I am going to divide this equation with equation number 1. What is equation number 1? It is 4.20 1.20 into 10 to the power minus 6, okay, divided by k into 1.0 to the power ex 0.15 to the power y. Okay, now we can simplify this. See, when you are cancelling this, this becomes 2, is it not 2? And now when you are cancelling this, this becomes 2, is it not? This also gets cancelled, this also gets cancelled, this gets cancelled, this gets cancelled. So 2 power ex, okay, that means 2 is equal to 2 power ex. That means x is equal to 1, okay. See here, x2 is equal to 2 power x, so x is equal to 1, okay. So the x values we have found out, like, okay, x is equal to 1. Like the same way you are going to find out the value of y now. So for that I am going to divide equation number 3, divide equation 3 by 1, okay, equation 3 by 1 to find out the value of y, okay. What is equation number 3 now? 5.60 into 10 to the power minus 6 is equal to k into 1.0 to the power ex into 0.20 to the power y, okay. Now divide this by equation number, what is that? 1, okay, 4.20 into 10 to the power minus 6 divided by k into 1.0 to the power ex into 0.15 to the power y, okay. Now when you are dividing this, you will be getting the value 1.333, okay, 1.33 is equal to, now this gets cancelled, this gets cancelled, this gets cancelled, this gets cancelled. When you are dividing this, you will be getting 1.333 to the power y, okay. That means y is equal to 1. So when you are comparing these two values, you will be getting y. So x value is 1 and y value is also 1. Now obviously it is possible to write the rate law, is it not? Using these two values, it is possible to write the rate law. What is the rate law? R is equal to, see, already we are having the general rate law. So now we are going to use the value of x and y here, so that you will be getting the rate law for this equation, okay. So R is equal to k into a power 1 b power 1, okay. So this is the rate law for this problem, okay. Now we are going to find out the order of the reaction with respect to A, okay. Order of the reaction with respect to A, okay. What is the order of the reaction with respect to A? So what is the power here? It is 1. So order of the reaction is obviously 1, understood? Next, we are going to find out the order of the reaction with respect to B. What is the order of the reaction? It is 1 is equal. It's not 1, okay. See, if you want to find out the overall order also, it is easy. How will you find out the overall order? Overall order. What is overall order? It is the sum of the powers of the concentration terms. Sum of the powers of the concentration terms. That means 1 plus 1. 1 plus 1 is equal to 2. Okay. So it is second order. Overall order is 2. But order with respect to A is 1. Order with respect to B is 1. And this is the rate law. Understood, students? Fine, students, you might have understood all the problems we have seen in this part 1 video. If you are having any doubts regarding formulas, you can go through my previous video on formulas and units. The link for the same is given in the description box. Okay, students, I shall meet you with the next set of problems in part 2 video. Until then, it's Anita Raj signing off from you. Thanks for watching.